see. Okay, guys, I've got people coming in here fast. Okay. Let's see. Brittany, Jessica, Isabella, Ella, Isabella, Allison, Christina, Sylvia. Okay. Guys, I want to start by I sent out an email last night about the video. A couple people let me know that I posted the Calc 2 video. That was a mistake. I didn't want you to see Calc 2. But I have fixed that. So far this week, I've sent somebody the wrong homework. I posted the wrong video in the wrong place. I'm whatever. It's just I'm trying to stay organized, and I'm sure, as you know, it's not always easy in a different space, especially the space that is my house. But anyway, while we're waiting for everybody to come in, are there any questions or concerns, guys, about just general questions, not specifically on the material, but general questions about things you need from me or things I can give you that might help, or just general concerns? Anybody? I like the bamboo wallpaper on Ella's. I guess that's her bedroom. Is that your bedroom, Ella? Okay, I like that. That's interesting. Is it on all the? No, it's only on one wall. Nice touch. Okay. Anybody question? Anybody else question? Okay. Kind of waiting for everybody to come in. I tell you what, while we're waiting for everybody to come in, again, where I'm working right now is a recipe for bad posture. So it's hard for me to, I just hunch over things. And you're probably doing the same thing, but do the best you can. And we're going to talk about, pretty soon, we'll probably talk about having another test, so it's not on so much material when we finally have one. I want to try to get a little further into chapter 4. Today we'll be doing 4.4, but yes, the last couple of days we've been doing 4.3. I want to know if anybody has any questions or problems on 4.3, because as usual in this course, what happens is that the prior section is very important to the next section, and that's what's happening. That's what's happening with this. Anybody, any questions or problems you're having with either setting up, finding those homogeneous solutions, what they have to look like, if they're real numbers, if they're complex numbers? Anybody have any questions on that? Somebody else waiting to get in. Let's see what we got here. Okay, Haley, I got Saron. Okay, all right, we're getting people in a little at a time here. Okay, there's Saron, I got her. Jessica, can't see everybody, but that's okay. Oh, there's Haley. Sylvia, okay. So anybody, any questions on the last? We're going to be doing more work on the last section today, because in order to do the section that I've got, we're going to be solving homogeneous things. So we'll get a lot more practice on that. There is a homework due on 4.3. It will not have anything to do with what I have to do, what I'm doing today. So that's due Friday. Let's just say Friday. I think I said before class, but it's not. I need it by 5, but I don't necessarily need it before class. Okay, so you might want to look at the last couple of videos if you're unsure about how to do anything on that, or just shoot me an email if you're confused about something on there, or something in general about that section. Okay, let me any questions, anybody, before I go to the screen? Or at least try to. It's been acting funky lately. Yeah. All right, there we go. Okay. So, somebody else coming in. Hang on, let me get them in. Tiara. Okay. I think we got everybody. We're missing, missing one person. I'm gonna roll beside me. I can't quite pick it out. But anyway, let them in if they come. So guys, what I want to look at today is section 4.4, and this is a method by which we're now going to talk about how do we solve non-homogeneous equations. Okay, so if we look at this thing and try to remember some things we got from the theory we did in that very long section to begin the chapter, a couple things I want to remind you of. One of those things is that when we talk about non-homogeneous, that this nth order dE is equal to some function g of x, not 0, but g of x. And at the very end of that long section that we talked about, we found out that if we were looking for a general solution of a non-homogeneous dE like the ones we've been looking at, it has this form: y equal yc plus yp. Okay, y equal yc plus yp, where if you remember, yc is the solution to the associated homogeneous. So that's all the things you've been doing in section 4.3 with the real roots, the distinct roots, repeated roots, complex roots. So it turns out that when we do a non-homogeneous problem, we're going to have to do all that stuff that we were doing back in 4.3. Okay. The other thing that gets added on is a particular solution that is particular to this function right here, that will make things come out right there. Now, in general, what happens when you plug in something like this, remember that a yc, or any multiple of, or any linear combination of solutions to that, will make this equal to 0. That's by definition, that's what it is. It's the definition to the associated homogeneous equation. And the yp is what, when it gets plugged in, makes you come out with the g of x. So when we do these problems, we're going to have to solve two pieces. We're going to have to solve the homogeneous piece, and we're going to have to solve this non-homogeneous piece, and then put them together in the end. So that's what a general solution is going to look like for the ones that we're doing right now. Okay. So that's what the general solution is going to look like. Okay. So so that's sort of what I've sort of talked through down here. So we learned how to solve the YC part. Now, how do we find a particular solution? Now, the method that I'm getting ready to show you is an interesting method. It's not particularly hard. It is messy, and you'll see that that what we have to do is sort of have to guess at a solution, but the guess is not. We can figure out how to do that. So for that reason, this type of method often is called the method of intelligent guessing. All right. So, and there's my brain skipping a beat right there. I guess it's an N. Okay. So based on the g of x that we have, all right. So based on the g of x that we have, this method, and it's called, if we go back to the, I'll scroll back down here a minute, it's called the method of undetermined coefficients, all right? The method of undetermined coefficients. And it works when we have functions for g of x, that is on the right-hand side of the dE, look like this, okay? We can use this method if we have a constant over there, if we have a polynomial. Those two are essentially one and the same. A constant is just a polynomial of degree 0. If we have an exponential, if we have a sine beta x, or a cosine beta x. Now, when we start to see how we do this method, you'll kind of see why it only works on these. But the reason I can give you up front is that because they all have the property that when they're differentiated, they come back as something similar. And what I mean by that is if you differentiate a constant, you get a constant. If you differentiate a polynomial, you get a polynomial. It's a lesser degree. It'll be at 1 degree less for the first derivative, for example, but it's still a polynomial. if you differentiate an exponential, you get an exponential back. Both sine and cosine, they're going to work together, guys. We're going to see these things work together. If you differentiate a sine enough times, you get the sine coming back to you. In particular, you can say for both the sine and the cosine, that happens, but remember how they alternate. The derivative of sine is cosine. The derivative of cosine is minus sine. So when you do this, when you look at a sine and a cosine, you're going to get a bunch of sines and cosines back. So we're going to kind of eventually look at these as a pair, because we get sines and cosines back when we differentiate sines and cosines. Okay, so that's the kind of functions that this method works on. So if we differentiate a polynomial, we get one back and that sort of thing. Now, here are the things that it won't work on, and you won't see these things in this section because it's ruled out really for this method. If I differentiate the log of x, I don't get another log x. I get a 1 over x. Okay, so it didn't come back to me as more log x's. If I differentiate tangent, is secant squared of x. Didn't come back to me as tangents. If I differentiate inverse sine, it's 1 over the square root of 1 minus x squared. Definitely didn't come back to me as inverse sines. It didn't even come back to me with things with sines in it. Okay, so these are things we are not going to be able to use this method on. Later on, we'll figure out another method to do those. But the process of doing DE is a lot like the process of how when you're in early grades in algebra, you talked about things you didn't know how to do. You didn't know how to solve a linear equation. You didn't know how to solve a quadratic equation. So it sort of adds on a lot of different methods for solving things. Okay, so question, anybody? You okay? All right, so here's how I'm going to start. I'm going to look at sort of the steps to this, and I'm going to show you, number one, why this is called the method of intelligent guessing. And it's because of the way those functions that we're going to use for g of x work. But when I try to solve a problem using this method, what I look at, clearly it's non-homogeneous with the g of x equal to 4x squared. The associated homogeneous is this one right here. The very first thing we're going to do with these problems is solve the associated homogeneous. Because as you'll see in a little bit, the solution of the homogeneous equation affects the particular, all right, or at least our guess for the particular, and we'll look at why that happens in a minute. But so we'll get some more practice doing this. I know that and I'm just going to cut to the chase on the characteristic equations, guys. We know that the characteristic equation here is m squared plus 3m plus 2. If I factor that, I'll get 2 roots. They're distinct roots, -1 and -2. That tells me that the YC, or the homogeneous solution to the associated homogeneous, is this one right here. Remember, you put in, there's the root right there, -1x and -2x. That's what the homework is on Friday. Solving that characteristic equation and then writing out what the YC is. Okay. So here's what I'm going to do. If I say that g of x is 4x squared, the guess that I want to make really is that what needs to be plugged into the DE to get that is another polynomial, okay? Because that's the only way I'm going to eventually get a 4x squared out of differentiating all these things on the left-hand side here. So because it's a 4x squared, I might say, well, I could get a quadratic in here and have a term of something times x squared. The derivative might have a term of 1 less power. The second derivative would go down again. So you'll get used to this as I start to look at it. So my guess for this one is going to be, I think that yp needs to be of the form ax squared plus bx plus c. Now, it's no coincidence that this thing right here, the 4x squared, is driving that thing right there. Again, it's got an x squared in it. I'm eventually may plug a y into the solution, so it needs to go up as high as ax squared plus bx plus c. It does not need to go any higher. It does not need to have a cubic value in it, okay? Because if you had a cubic value in it, you might put in that cube right there and not be able to get the 4x squared. So what's happening here is that I am guessing that it's a generic polynomial that looks like that, all right? Looks like a quadratic. So, that capital A and capital B and capital C are the coefficients of this thing. And the reason we call this the method of undetermined coefficients is because our goal is going to be to find out what A, B, and C are. And if we do, we can find a YP. So I'm going to do what I typically do in solving some of these things. If I knew a solution and I wanted to check it, I would take all the derivatives that I need. I don't know a solution here, but I do know kind of a form of the solution. So if I say YP is this, YP prime is going to be 2ax plus b, and YP double prime is going to be 2a. I'll do exactly what I always do. I'm going to take these three things and plug them back in to the original equation. All right. So let me show you, I'll show you what I did here. Y double prime, the first one here, y double prime was 2a, so that's what that thing is, y double prime, plus 3 times y prime, there's the 3, that's the y prime, plus 2 times y, there's the 2, and there's the y right there, all right? And that's equal to, that needs to be equal to 4x squared. Now, guys, you might see what I'm getting ready to do coming, because this left-hand side right here is just a bunch of polynomial, it's a polynomial with these unknown coefficients on it. So what happens is if I can figure out what those coefficients are to make this 4x squared, I'll be able to have a solution. And here will be the solution. Figure out A, B, and C, and you've got a solution. So, so what I'm gonna start to do is just multiply everything out. Okay, I just multiplied everything out here, and you may or may not need to multiply everything out. You may be able to see this without doing that, but for our first time here, I'm going to do that. And then I'm going to group things together. So when I look at this, then I am going to look for all the constants through here. So the constants here are 2a, 3b, and 2c. So 2a, 3b, and 2c. This can get really messy, guys. I would encourage you to strike through things as you use them, so you make sure you get everything in there. So I've taken care of 2a, I've taken care of 3b, I've taken care of 2c. I did not strike through when I first did them, and I'd missed the 3b. I thought it was another, maybe had an X on it or something, but make sure you look through and you get everything. The next thing I'm going to do is look for all the ones that have an X term in them. And the two that have the X term in them are 6ax and 2bx. So 6ax and 2bx, there's 2bx, there's 6ax, is going to be 6a plus 2b right here times x. I only have one more to account for, and that's 2ax squared. So I'll have the 2a there is the only one of those. Okay, so those are all taken care of. Now, this is probably going to remind you of something in Calc 2. If I want two polynomials to be equal, or any kind of things to be equal, I've got to match the coefficients on either side of the equation with the right term. So if you look at the right-hand side of this thing, and think about what it is, it's 4x squared plus 0x plus 0. If you look at it and say, well, yeah, that's a quadratic. So if I look at the left-hand side, and the easiest one to look at here is this one right here. The coefficient on x squared is 2a, and on this side, the coefficient on x squared is 4, so I need to set 2a equal to 4. Does this remind you of anything in Calc 2? Anybody remember anything? Mike, if you think of anything that reminds you of in Calc 2, where you were matching coefficients on either side. I just talked about it in Calc 2.
Partial fraction.
Yeah, exactly. It reminds you of partial fractions, okay? Because that's what you did with partial fractions, to find out how you could break up that rational expression so it was easier to integrate. So I've got a hold of one of these things now. A is 2. So the rest of these things, this one, 2a plus 2c plus 3b is the constant. Well, the constant on this side is 0. So I take that one and I set it equal to 0. And then finally, I take this one, that's the coefficient on x, and I set it equal to 0. So 6a plus 2b is 0. So I just matched the coefficients. Now, guys, you have the potential here of getting systems of equations, but a lot of times for these things, because the powers on x's are dropping, you'll be able to find one and then maybe use it to find another. So an example of that would be right here. Since I already know a is 2, and I know 6a plus 2b has to be 0, I'm just going to go ahead and plug in my 2 that I know a has to be. So there I'll get 12. I move the 12 over, I get 2b is minus 12. That says b is minus 6. Okay, so I'm in business now. Go back to the very last one. I know a, I know b, I can find the only one that's left to find, and that's c. So when I put in a equal 2 and b equal minus 6, I'll get minus 14 on that side. Moving it over, I'll get 14, I'll get c equals 7. Okay. I have essentially solved for the particular solution now. All right, let me move it up a little bit. Any questions, anybody, on what I did? It's a fairly easy process. It can get messy, all right, but it's an easy process. So what I found here, because of what A, B, and C were, that the particular solution looks like 2x squared minus 6x plus 7. That being A, that being B, and that thing being C. Now, you haven't finished the problem until you write the whole general solution. And the whole general solution consists of the YC plus the YP. Again, if I were to take that to the original DE and plug it in, all of this stuff would cause the DE to be 0. If you put this in, you should get 4x squared on the other side. So if you want to do a quick check on whether your particular solution works at all, you could plug this thing in. You could take the derivatives on that, plug that thing in, and verify you get 4x squared. These things are the homogeneous solutions, so they cause things to be 0. Okay, so we've done our first one. Now, it is important here that you do write this entire thing, because later on, we're going to be looking at problems that we have conditions for. And we're going to want to find C1 and C2 for certain conditions. So this is what you're going to be plugging in to when you're trying to find, satisfy a DE with certain conditions. Okay. All right, let's look at another example. Okay, let's see. Let's look at this one. Okay, so 3y double prime minus y prime minus 2y is 2 cosine x. First step again, I need to find my YC. So that's what I'm doing here. It's 3m squared minus m minus 2. Yes, my brain's skipping a beat again here. Let's see, what do I need there? I need a minus 1 right here. There we go. I know what that is. I'd made a mistake and I white things out and I forget to go back and put them back in. So 3m plus 2 times m minus 1. Once again, we've got real roots. They're distinct roots. So what we'll have is a YC here that we'll need later. There's the YC right there. It's C1 e to the minus 2/3 x plus C2 e to the 1x. To find the general solution, I'll need to add the YP onto that. All right, but that's the very first thing we always do. Okay. Question, anybody? We okay? All right, so I look at my g of x over here, and I say, what's my guess for that? What's my intelligent guess? This is not just a guessing process, it's an intelligent guessing process, because you have to sort of get a generic solution that out of which would come some cosines. So you might think, well, maybe I just need to make this thing look like a cosine theta, or not theta, but x in this case. Okay, a because we don't know what the constant might be. So a cosine x, but that's not going to be enough, because if I were differentiating that, not only would I get cosines, I would get sines. As a matter of fact, in the next derivative, I'm going to get a sine. So here's the guess we're going to make for that. We're going to say that yp is some combination of sines and cosines. Okay, it's some combination of sines and cosines. All right. So I'm going to, and I don't know what the coefficients on them are. That's what I'm trying to determine. Again, this is the method of undetermined coefficients, yet to be determined by me. So, so I write that, and then I do the same thing. I take the derivatives of each one of those. So in the first case, this right here, y prime will be minus a sine x. Keep straight on your signs here, guys. If you make one sign error or one slip up on something, this method just will crash, okay? And you will not get an a, b, and c that work, or a, b, and whatever you need. The derivative of this one is b sine x plus b cosine x. I know it's a second order equation here. I'm going to need one more derivative to plug things in. So this will be minus a cosine x. This will be minus b sine x. So the next step, and really in a sense, the most important step, is you make your guess, you take its derivatives, and then you start to plug in. So what I'm going to plug into is, of course, the original equation over here on the left. And it's going to be 3 times y double prime. So I put that in right there. Minus y prime. And there's y prime right there. So this is what this is. And then minus 2 times, and again, I'm looking at this thing, minus 2 times y, and y, of course, was my original guess of this. What we want that to equal, of course, is whatever was on the other side, which in this case was 2 cosine x. Now, guys, I don't know what to tell you about whether to write all this detail down here or not. I'd rather you kind of watch me in a sense, and then I'll leave it on the screen longer if you want to see it and write some of it down. But if you get the process, you can kind of check on it later. But let's go down to this. So that's where I've plugged things in. I want it to equal 2 cosine x. So if I look through this whole thing up here, I'm going to have constants times cosine x's and constants times sine x's. So I'm going to group it like that. I'm going to take all the ones that have a cosine in them, and I'll look at that here. That's minus 3a. All right, minus 3a, and there's a cosine right there. That's going to be a minus b. That's where I get it there. Be careful, and I'll tell you, because I made a small error when I was going through it, and the whole thing messed up. If you have to go, I have to go to another line here because this screen I'm working on is so short. If you have to go to another line and there's a minus in front of it, don't forget that. Okay, make sure you got the minus shooting through here. So the other thing that's got a cosine on it is minus 2a. So that's where all of this came from, were the coefficients on the cosines up here. Okay, I'll group together the sines, and I'll have minus 3b, minus a minus a, there's a sign right there, so that'll be plus a, and then with the minus here will be minus 2b. So there are the grouped coefficients on sine x. Now, Now is where we start matching sides, matching coefficients on the various sides. There are no cosines over here. I mean, sorry, there's a cosine, but there's no sines. So the coefficient on the sine over there is 0. So I start then to write my equations. I would, if I were you, combine these things before I start with the systems of equations. It'll make it a little easier. Minus 2a minus 3a is minus 5a. So minus 5a minus b is the coefficient on cosine. Over here, the coefficient on cosine is 2. So I'll set this thing right here equal to 2. The coefficient on the sines, if I combine these things, that's minus 5b plus a. There are no sines over there, so the coefficient is 0. Start with 1. Now, how you do this is totally up to you. I have 2 equations in 2 variables here. I briefly considered lining them up under each other and doing elimination. That's fine. I really don't care. But this one's so easy because it's set equal to 0 that I just moved the 5b over here and found out that a was 5b, and then I plugged it into that one. Okay, so I'm using substitution. You can use elimination if you want to. Either way you can get that system solved. So I've got minus 5 times a, which I know to be 5b, minus b equal 2. If I multiply through here, I'll wind up with minus 26b equal 2. Hence, I divided by minus 26 on both sides, and I got b was minus 113. So I've determined one of the coefficients already. Now it's easy to find a. Go back up to here. You know that a is 5b. b is minus 113. So I get that a is minus 513. Okay. So here's what my solution looks like. Remember that my guess was a cosine x plus b sine x. So I write the YC that I found initially. And then my a was minus 513, so I put that on the cosine x. And my b was the minus 113 sine x. Okay. You could check that. It would be messy, all right? If you want to do a really quick check and you feel pretty confident about your YC, you could take this, plug it in, and verify that you get 2 cosine x on the right-hand side. So that will work. Okay, so we've gone through 2 examples. I'm getting ready to sort of move it up a notch here, guys. What kind of questions do you have? Does everybody see what the process is doing? Are we okay with that? All right. Okay, I'm not hearing any screams or anything in the background, so I think we're doing okay. All right. So let's move on to one other thing here. Not only will all of those functions that I listed work, but any linear combination of those things. Now, for example, any linear combination of sines and cosines would work. Okay, so I could have had on that other one, I could have had 2 cosine x plus 5 sine x, and I could make a guess for each one of those, which would involve sines and cosines. More to the point right now, let me do one that's a linear combination of some easier functions, maybe not sines and cosines. Sines and cosines are fine, but they're maybe a little harder to differentiate. Although I will say in this one, it can get messy when you have this form. Now, what do I mean by this form? First of all, when I look at that first piece of this, now this is my g of x. This whole thing right here is my g of x. So when I look at that first piece, I see that that's a polynomial, okay? This, on the other hand, is something that has to do with an exponential, okay? And the coefficient on that exponential is a polynomial. So I've got these linear combinations of a couple of the different kinds of functions that I had, polynomials and the e to the alpha x's. First step, as always, solve for YC. My characteristic equation is m squared minus 2m minus 3. When I factored it, I got this. Here's my solution right here. So that's my YC. Always your first step. Now, let's talk about a guess for YP. If I look at what would give me a 4x minus 5, that thing is linear. And in much the same way, when I had a quadratic one a minute ago and sort of gave you a generic quadratic as a guess, this one I'm going to give you we're going to make a generic a generic linear as a guess. So the guess that goes with that part of the function right there is ax plus b. It's a generic linear thing. Okay, that's where I'm going to get linear things when I take linear things and differentiate them and so forth. Now, this one's a little different. It is an e to the x, but it's also a polynomial times e to the x. So I have to account for the polynomial and what it would do with the e to the x. So it's also linear, and I'm going to replace that one, that linear one, with just the generic thing I think its derivatives have to come from, and that's going to be cx plus d. Now, guys, before I realized what I was doing, I put cx plus d here, that's linear, and then it's times the e to the 2x. Your book would have written ax plus b plus cx plus e here. It skips d. And the reason it skips d is because of some of that operator notation we were talking about a week or so ago. Right now, I'm just considering it as any constant, okay? I kind of found myself doing that. I was like, I shouldn't be doing that because it might look like an operator. In operator notation, this would be saying d, the derivative of e to the 2x. In just multiplying by a constant, it's just the constant times e to the 2x. It's not operating on e to the 2x at all. So my bad on that, but you will see your books kept A, B, C, E, F, G when it needs these things, okay, without using the D. Okay, so that's my guess. Now, here's where I probably want you to, I'm gonna differentiate these things, and then I'm gonna plug it in, and then I'm gonna try to kind of spare you the agony of what's going on here, and we'll just look at all the details. I did go through all the details to make sure I got the right thing, but we'll just look at that. So take your y right here. It's probably better if when you have this one right here, this cx plus d times e to the 2x, is to go ahead and multiply it out, because there are going to be some terms of it that are easy to take the derivative of. And then this one, the derivative of that one's easy. The derivative of this one, what would I have to use on the derivative of cx e to the 2x, guys? To find the derivative of that, what would I have to use?
The product rule?
Product rule, exactly. I'd have to use the product rule. So you can see that this is going to get a little messy. So the first thing I'm going to do is take y prime. Fortunately, the derivative of ax plus b is just a. So that's nice. The next one, the cx e to the 2x is the first cx times the root of the second, which is 2e to the 2x, plus the second e to the 2x times the root of the first, which is c, plus the derivative of this one, of course, is just e to the 2x times 2d. Now, this gets a little messy, but again, we just go through and take the derivative. We've got to take, I then, I don't know what I did. I thought I was simplifying it, but there wasn't much to simplify. So a plus 2cx e to the 2x plus c e to the 2x plus 2d e to the 2x. Okay, so there's my y prime on the last line there. Okay. After that, I got one more derivative I've got to take. Okay. So I will take this thing right here and take its derivative. Derivative of a is 0. This thing right here, I'm going to have to use the product rule on. So these are product rules begetting product rules. I can't say that. It sounded biblical, but whatever. You get lots of product rules in it, okay? So it's going to be the first 2cx times the derivative of the second, 2e to the 2x. The derivative of this one's just going to be c 2e to the 2x. The derivative of this one is, let's see, 1, 2, this time's derivative of that. Derivative of that one is 2c to the 2x. Derivative of this one is 2d e to the 2x, but when you bring the 2 down, you're going to get a 4 there, okay? So you see what's happening here. This is why I only teach DE about every third year, because I think when I'm grading these papers from you guys, I'm going to go blind, all right, because there's a lot of stuff to check. All right, so what I did was, what I've been doing is taking the those things that I just found, the yp prime, the y up here, let me get that back. Okay, the y up there, the yp prime, and the yp double prime. Simplify as you go, and maybe you won't have as much stuff to plug in to your DE. But at this point, I got to plug into my DE, which was this part right here was y double prime minus 2y prime minus 3 times the y. Okay. Now, here's where the mess starts. It's not hard. You just have to be extremely careful with this. When I look at, and again, I'll leave it up here, guys, if you want to write it down. But you can sort of see what I'm doing. I go ahead and I start to multiply all this stuff out. I make sure my signs are good. I check it a couple of times before I start striking things here, guys, because that's where you're going to make the errors when you go through here.
Dr. Harrell, quick question.
Yeah. Haley.
When you took the first derivative, where does, so I see the a drops out from the ax, the b goes to 0, and I see you have 2cx e to the 2x, because you're going to multiply by the chain rule there.
Yeah.
Where does
This is the one we're looking at, Haley, right there.
Yeah.
So I get a, and the derivative of b is 0. This one I've got to use a product rule on. That one right there.
Okay. Okay. So you use the product rule. Okay.
Yeah. This thing right here came from a product rule on that thing right there.
Okay.
And then the other one came from the last term.
Okay. That's what I need. Thank you.
Is that good? So guys, I tell you what, you can write down the simplified derivatives if you want to, and then you can sort of wade through what I'm trying to do. Okay, I'll give you a minute or two there. I'm going to roll it up a little bit. So there was my guess right there. All right. So, all right. So guys, once I plug all that stuff in, I'll just show you where I am now while you're copying things. And the process itself is not hard, but you can see where it's messy, definitely messy. Okay. So when I simplified all that stuff, and I could see some things that dropped out, and that's, first of all, let me tell you about how I do this. And you guys have all had out as much algebra 1 and 2 and 3 as I have, okay? And you know where the dangers are here. But if you look, when I look through first, I look to see if there are any terms that just drop out, because that simplifies my life right away. And what I saw on this one was 4cx e to the 2x and minus 4cx e to the 2x dropped out. So those were gone. I don't have to worry about those anymore. I may have some more of those terms, but that dropped out, okay? At that point, I looked at the terms I kind of had left. I had an e to the 2x terms. I had some constant terms. I like to kind of go ahead and take care of the constant terms because they're fairly easy. So minus 2a minus 3b were my constant terms, and they ended up right here. So I've just went ahead and struck those. And this is just hints from somebody that's done this a lot, and sometimes I tend to be on the careless, I've got to hold myself in check not to be careless, okay? So now I looked at, I marked them, if I look at this, I've got some of these constant times e to the 2x terms. There's one of them. I had already looked through some of these, but I've got, there's one, and there's one, there's two there, there are four there, and so on. And I look through those until I figure out how many there are. And those are my, sort of my terms there. Then I'll sometimes use checks to combine the other ones. When I got all of this stuff combined on the left-hand side, I was looking at x e to the 2x terms. I was looking at just e to the 2x terms. Here were some more. These are both e to the 2x terms, so I could have combined these in a way, and I'll do that in just a second. There's a minus 3ax, and there's a constant. All right, so that's all the terms, and then I go back and I check and make sure I've got everything. I'm gonna roll it up a little bit. Can I roll it up, guys? Is everybody okay to that, down to here? You see what I'm doing? I'm just striking things. All right, so let's look and see what we got. What we want it to be equal to is that thing right there. So when I look at the x e to the 2x terms, that is the only one there. It's the only one that's left. So there's an x e to the 2x term right there in this one. So that tells me that minus 3c has to be 6. So I've matched the coefficients there. Go up a little bit. So that's what I wrote right there. Okay. The other term, there's other terms. There's e to the 2x terms. There's one of them, and there's one of them. That's a 2c. That's minus 3d. There are no e to the 2x terms over here. So the coefficient on this one, you could do this if you wanted to go a little further. You could have combined them. And the coefficient there is 2c minus 3d, but I know it's 0 because there are none of those terms over here. Okay, so that's where I got my second equation. So I've accounted for those terms there in terms of the matching. This one, minus 3ax, there's one x term over here. That means minus 3a has got to be 4. See that? Right there is an x term, and right there is an x term. Okay, so that's where I got minus 3a equal 4. The last thing that needs accounting for, so that one's gone, is this constant thing right here. Minus 3b minus 2a. The only constant I've got on this side is minus 5. So minus 3b minus 2a is minus 5. Okay, now you got smooth sailing. And by the way, these things, like life, these things don't always come out in whole numbers. Okay, so don't expect it. Don't even dream about it. Okay, they might come out in whole numbers, they might not. But when I get to this point, I'm in pretty good shape, because I know I can solve a system, being careful enough and so forth. I will do what I did the last time, though. I'll look for the easiest thing. That thing right there is the easiest thing. A is minus 4/3. Okay, so I've got to hold on one of them. Now, if you were to write this in matrix form, guys, it would be 4 equations in 4 variables, and it would be the matrix we would write that would be what's called a sparse matrix. A sparse matrix has a lot of zeros in it, and a lot of these equations, for instance, this one won't have an A and a B in it. That one won't have a B, C, and a D in it. This one won't have A, B, and D in it. You get the idea. I'm not gonna bother to write. I mean, I might have to in some situations write the system of equations and solve it, but in this case, I can get a hold on one of them, and by getting a hold on one of them, I can get the other one, and if I get those, I can get the other ones. So that's easy. There were actually 2 easy ones here. If minus 3c is 6, c is minus 2. So I've already got 2 of them right there. By the way, I posted on Moodle, I just sat down with my calculator and sort of wrote down what you would do to solve a system of equations on the calculator. There are probably some shorter ways to do it, but I just sort of put just showed you what you needed to do to go through and find a solution, which has to do with putting it in reduced row echelon form. Guys, reduced row echelon form, let me just back up just a second. We've almost finished this one, but reduced row echelon form for a matrix, at least for the ones we're going to be looking at, comes like this: 0, 0, 1. You've put all your elements in your matrix. In the end, when you put it in reduced row echelon form, you might get something like 2, 3, 4. Well, these were the reduced coefficients on x, y, and z. That says there's no y's and z's in that first equation. So x is 2, y is 3, z is 4. Now, when you're looking, I don't know how many of you are familiar with doing this on the calculator, but there are 2 commands on the calculator, and I don't know how many of you had linear algebra. If you had linear algebra, this ought to be a piece of cake. There are 2 commands on the calculator. One's REF, which is which is row echelon form, and RREF. That's reduced row echelon form. Okay, so you are looking for RREF if you want that right there. So you want RREF on your calculator, and REF comes first. So just don't be snagged into pressing that one. That's not the one you want. You want RREF, which is right under it. Okay, that stands for reduced row echelon form. It gets it in a particular form that you'll learn about in linear algebra if you hadn't already taken it yet. Okay. Okay, so I'm gonna spare you the details here. Notice that if I knew that C was -2 and A was -4/3, I could put in C here and find D. I did that. In this one, I could put in A, which I did, and find B. So the final solution is take the YC, so C1e to the -x, C2e to the 3x. Now remember what your proposed solution looked like. It looked like AX plus B. So this was my AX plus B here. I found out that A was -4/3, B was 23/9, and then the other one was, my guess was, and I did it in the multiplied out form, but if you remember, it was CX plus D times XE to the X, I think. Yeah, XE to the X. Okay. So when I put my C and my D in there and multiplied it out, that's what I got there. Okay. You can see the -4/3 and the -2 there, the C and the D. Okay, which was -4/3.
Can you scroll up back to the when you were simplifying that just mess of stuff?
Yeah, there it is, and it's all marked on. Haley, do you have a particular question, or are you just trying to write it down?
Yeah. Sorry, that was on my pens.
Okay.
I think I just need to go back and look over it because I'm not seeing like some of the crossing out. I'm not getting where you cross.
Okay. Well, as I'm crossing, that is kind of hard to see. But let me do something here.
See, okay, so 4C e to the 2x. Okay.
I'm gonna get rid of this for a minute, okay, and show you sort of what I did as I was working it. I looked at this and this, and I saw immediately that they would drop out.
Wow.
Okay, so that's gone. I then looked at the constants, the 3b and the -2a. So I dropped that out, and it's going to be right there. Okay.
Why does that drop out?
Well, it doesn't drop out. I shouldn't have said drop out. It combines together in the end. When I go through all this stuff, I'm going to have a constant left. So there's no need for me to junk up what I'm looking for every time with that. I'll just go ahead and put it down here because that's all the constants.
Okay.
Does that make sense?
Yeah. So the only thing I'm seeing that cancels out just like completely is the 4cx e to the 2x and the negative 4cx.
And you're right. And you're right. That's all. That's really all that it does.
And that 2ce, that negative 2ce to the 2x. Yeah, I don't. That's where I'm losing. Yeah, I don't know where what happened.
All right. So look at this. Negative 2c e to the 2x. I'm gonna circle it. Okay.
Okay.
Negative 2c e to the 2x. There's a 4c e to the 2x. They both had x's on them. Okay. I don't see any more e to the 2x terms here. I see a cx e to the 2x, but I don't see any more. I do see one more e to the 2x, and it's right here. But look at these. These are c's. So what do you get when you combine those two?
You'll get 2.
2. So that's what that one is.
Okay.
Okay. So those are gone. I do have another e to the 2x, and it was the one, the e, let me see, where did I go? Oh, look at this. Okay, I'm going to start circling again, okay? These two lines go together. So I'm going to look at the d things. So there's a 4d e to 2x. There's another 4d e to the 2x, and it's minus. So you know what? That one's gone. Okay, so there was another thing that dropped there, wasn't there? See that plus and that minus d e to the 2x?
Yeah, I had to. I just.
Okay, so that's gone. The only other d e to the 2x that's left is that one, and I have it right there. Okay, so now what's left? What is left? That was my ax is here, minus 3ax there. That was right there. So I put that right there, and then the rest of it was my constants. It's hard to, if I have my big chalkboard, this would be big black whiteboard, this would be easier. But they will all combine and drop out. You got to be systematic. I guess what I'm saying is you got to be systematic about combining the things.
Okay.
So Haley, did that help?
Yeah, I got it now. See, I just got off on trying to catch up, and I was like, I missed the simple.
Well, and that's, yeah. I mean, I get it, and that's because it took me a little while to do this. It took me a long time to do this lecture last night. I thought I'd be through in an hour. That was kind of stupid. But anyway, that's where you have to be careful right in there.
And that negative 3c to the x e to the 2x. That doesn't combine because it has that x in there.
Yes, absolutely right. Absolutely correct. Okay, it does not combine. That's again, that's sort of where on this one and this one, I sort of checked it right here, and I said, well, there's one that's going to correspond to that. That way I know that minus 3c is going to be equal to 6. And did I not write that down here there? I might not have written that down in there. Minus 3. I left it alone there. Pick your own, pick your own way to do this. Sometimes I see things and I go ahead and do them. Okay. All right. Anybody else question about that? And it just looks like a horrible mess, and it sort of is. Okay. Okay. So let's go to an easy one. Actually, and this is important. There is a glitch in this method, and I'm going to show you what that glitch is right now, and you have to be careful with that. And that's sort of what I want to finish up the lecture talking about. Let's take a look at this DE right here. Fairly simple. It's not going to look anything like the last one, okay? But my guess on this one, if I just look at g of, well, first of all, I find yc. It's going to be m squared minus 4. It's got 2 roots, 2 and minus 2. So I get yc is c1 e to the 2x plus c2 e to the minus 2x. Okay. My guess is a, because that's just a 2 there, e to the 3x. And my y prime is 3a e to the 3x. My y double prime is 9a e to the 3x. Differentiating that again, that 3 comes down and gives me a 9. Plugging all that in here, there's your y double prime. There's your minus 4y. And we want it, there's our guess right there. I probably shouldn't have written that in there, but there's what I want it to be right there. There's what I want to match with. So this one isn't too bad, because if I look at the e to the 3x, that says, and I really, let's see, okay, so there's this minus 4 times that is 2e to the 3x. That says that right here, if you subtract those two things, oh, I did need that there. These are terms, and sometimes it's hard to even see the terms to combine. But 9a e to the 3x minus 4a to the 4a e to the 3x is 5a e to the 3x. I want that to match on this. It's easy. A is 2/5. So here's what my solution looks like. Okay. 2/5. There's my A, e to the 3x. There was my proposed solution. I found out what A was. Yeah, I combined these two things right here. That happened because this was a simple function. It's just going to keep repeating e to the 3x's times a different constant every time when you take the derivatives. All right, now I want to do another one. Notice on this one that the left-hand side, that is the dE itself over here, is exactly the same. So my YC is going to be exactly the same. Okay. So my right-hand side looks exactly like this one did, except I changed it a little bit. I changed it to an e to the 2x here. And it's still got a constant on it. So my guess here is going to be a e to the 2x. All right, it goes slow and allow you to catch up. I'll do what I always do. I'll take the derivative of these things. I need a y double prime because it's a second order dE. So here I'll get a e to the 2x. Here I'll get 2a e to the 2x. And then 4a e to the 2x. I'm going to plug those things in just like I plugged them in up there. Y double prime was this minus 4y. My y was this, okay, a e to the 2x. And I want it to equal 2e to the 2x. I want to match coefficients so it equals 2e to the 2x. But look at this left-hand side down here. Up here where I combined, I got 5a e to the 2x. I could easily match the 5a and the 2. What happens down here, guys? What do you see right there? And you differentiated that thing twice. And they had a, the way we plugged it into the solution, we had a 4 here and so forth. We got 4a e to the 2x minus 4a e to the 2x. And that's equal to what? Not regardless of what you got down here, that's 0. So you come into a sort of a problem here. What you got when you plugged everything in on the left with your proposed guess was 0. Now, so that can't happen. This is never 0 right here. 2 times e to the x is never 0. So this cannot happen right here. So what happened with the method that caused that to happen? All right, is everybody okay? Is everybody with me so far? I want you to look at your YC. And I want you to look at your proposed guess. Do you see anything that might have caused some zeros to happen when you plugged it into the left-hand side that didn't happen up here when it was e to the 3x? You see anything connected to the YC and the initial guess? Anybody? You see anything connected here? Anything similar that wasn't similar in the one before when I had e to the 3x there? See anything similar? Your eyes are probably crossing at this point by looking at all this stuff, but I want to point out to you this. In your proposed guess, it was part of your YC. See that e to the 2x in both of them? That's a problem. Because any linear combination of e to the 2x gives you a solution to the homogeneous one, which means when you plug this in, because that e to the 2x was here, and this is a constant multiple of e to the 2x, it caused the left-hand side to be 0. It was part of the complementary solution. You cannot make a guess that has in it part of the complementary solution because it's gonna get sucked up in the complementary solution and it's not gonna contribute to the particular solution. Okay. So let me see if I can make that a little clearer here. So what I said was that there's a glitch in the method. What I just did was kind of say what the problem was. And the problem was that your proposed guess was already included in the complementary guess. That can't happen. We cannot have that happen. So the question is, what do we do? All right, so we're going to make kind of a next best guess. Let me get this out of the way here. We're going to make a next best guess. We need to guess something that has e to the 2x's in it, guys, and whose derivatives have e to the 2x's in them. But it can't be just an e to the 2x. The next best thing, and the next simplest thing you could do, is take your original guess and instead of multiplying it by a constant, now the constant doesn't work because if it's a solution to the homogeneous one, any constant times that's going to be a solution to the homogeneous. I'm going to add something that's non-constant here and it'll be a power of x. In this case, that will allow me to avoid anything that was in that original guess. Now, here's my lesson learned. Okay. The solution of the associated homogeneous equation has an effect on our educated guess. That's why you have to do it first. You may have to change your guess. If your original guess, I'm going to start calling it the initial guess. If your initial guess has anything in it that is already in the complementary solution. Okay, so long and short of that here, no function in the assumed YP, I like to call it the initial Y, it's our initial guess. We'll make an initial guess and say, okay, will that one work? It will work if it doesn't appear anywhere in YC. And what I do to fix it is I say I'm going to multiply it by x. Now I want to make a comment here. I'm going to spend a whole nother day on this tomorrow, guys. But what I want to do is make one more comment. Suppose I had a guess that looked like this. I mean, sorry, a YC that looks like this. Suppose I had a YC that had an e to the 2x and an x e to the 2x. Guys, remember that would denote a repeated root. Remember when I had a repeated root, I did e to the 2x and then x e to the 2x. If it had been repeated again, I would have had an x squared e to the 2x. If I'd had this, even this wouldn't be good enough. Because notice, it is repeated in the YC. So guess what I do? I make it an x squared. I make the power on x here high enough to avoid any of these conflicts here. We'll talk more about that tomorrow, okay? So that's what I do. But let's finish up this one and see what we got. again, guys, this is a messy one. I'm going to try another one. And let's say, and by the way, I didn't finish up that other problem. You could finish it up by putting this in there as your YP equal. We would put, since there's an X there, my next best guess would be X times that, it'd be AX plus B times e to the 2x or whatever. We get to avoid those things. All right.
Dr. Question.
Powers of x. Again, let me do one more problem with this and we'll call it quits. And we'll talk more about this tomorrow. Okay, so suppose I had this thing right here. Y triple prime plus 9y prime is your DE on the left. And my roots are m equals 0 and m equal plus or minus 3i. If I write the y, if I look at what the YP is for that, this is my initial guess. Look at the YC. And this is why you have to be so grounded in the last section. I've got a root of 0, so that's C1 e to the 0x, plus I've got this complex root, the part of which, the real part of which is 0. So that's where this comes from, e to the 0x, times C2 cosine 3x, that comes from the imaginary part, plus C3 sine 3x. I look at that right there. That's my YC. I go up here to make my initial guess. My initial guess is, that's a quadratic, so ax squared plus bx plus c times e to the 5x, minus, this is a cubic. It's a cubic polynomial. I'm going to put in dx cubed plus ex squared plus fx plus g. It's times cosine 10x, so I'm going to have times cosine 10x plus sine 10x. That's what I have to do. I have to get a combination of sines and cosines there. All right. Now, look at this and see if it conflicts in any way with this. It doesn't, guys. And the reason it doesn't is because I have sine 3x's and cosine 3x's here, and my guess has sine and cosine of 10x's. So you don't need to worry about any conflict there. All right, and there's no, there's your YC, there's a constant there. Okay, so if you don't see any conflicts there, you can just proceed. Case 2 is if there is a problem. And if I look at this one, there's the DE, it's equal to e to the x. The YC, that's a repeated root. So it'll be C1 e to the x plus C2x e to the x. My initial guess, because of this e to the x, is a e to the x. But you know what? There's a constant times e to the x term. That's no good. That would be sucked up in this piece. So let's move it to another guess. Ax e to the x. Let's add one more x. That gets sucked up in this piece. So that was no good either. Neither one of those are any good because that one has a constant times e to the x in it. This one, this YP, when I bumped it up a power, had this one in it. So my next thing, bump it up another power. There's what I need to start with. So my initial guesses didn't work. I bumped it up until I did not see a term like this, and that's just a constant, guys, in there. Now I just do what I always do. I take the derivatives, I match everything, and I'm done. So here's the rule, and this is what I want to end on today. We will do more of this tomorrow. If any YP contains terms that duplicate, let's see, that duplicate terms in YC, then that YP must be multiplied by x to the n, where n is the smallest positive integer that eliminates the duplication. Okay. Like I did up here. I had to keep going until I eliminated the duplication here. All right. So, guys, what I want you to do for homework tonight, I want you to try a few of these. I put everything on there for the homework for Wednesday and Friday. So we're going to be working again on this Friday, but there's one thing I want you to look at. And I usually use it as a class exercise on the same day. On Moodle, there is a document called Practice Guessing. Practice Guessing. And what I've asked you to do is not to solve the DE, but to look at the YC. You need to solve the homogeneous part, but then make a guess based on your YC what your YP should be. In other words, you're going to make an initial guess like this one, and maybe like this one, all right, this one, and then you're going to get your final guess. If you'll just take a look at that, and if you have, do a few of these to make sure you're grounded in the method right now. And then look at that practice guessing thing, and we'll go through a lot of these things, because the most important thing here is to get the right guess. If you don't get the right guess, things are going to go off the rails, like a minute ago when we had 0 equal to e to the 2x something. Okay. All right, I got a lot more to do with this, so concentrate on your homework from last time. That's really important, the homework that's due Friday, because it's all the YC stuff. And you're going to have to know the YC to be able to do this. Do that first. All right, send it to me whenever you finish. And then start working on a few of these. And look at that practice guessing sheet, and we'll come back and we'll work on a lot of those. Okay. Anybody have, nothing's ever as easy as it seems from the beginning of the lecture. Okay, it got complicated in the middle here. Questions, anybody, about any of this?
I have a question about grades.
Okay.
And like, I know the 20th deadline is coming up next week. Can we email you individually to see where our grade is?
Yes, that's what I'd like for you to do, guys. Everybody's in sort of a little different situation. So that it's April 20th, and that you said that's right, Haley.
Yeah, April 20th.
That's when the pass no credit, you choose pass no credit, or you choose you want a grade. That in the end, guys, I can always override that at the end of the semester, but you do need to know what you want to make as your initial decision, okay? So email me. I'll be happy to talk to you about what I'm looking at in your homework and your tests and so forth. We're probably, when's the 20th? That's a week from yesterday. We're not going to have a test before then. We're not going to have another test before then, so I'm going to have to project. But I'll tell you what I think could happen in each of your cases, okay? Anybody got a question about that? That's a good question, because that's coming up. Another issue in this far from normal semester.
Same kind of deal. So I was talking to Dr. Guzman the other day, and she said that like y'all have to have permission to like give us a grade. Like, say if I never filed anything but I still went up with an A, that you just can't give me an A without my permission.
Oh, I will, trust me, guys. I will do whatever I need to do and consult with you. By permission, she means we've got to go to the registrar's office and manually change it.
Okay.
And that's okay. I mean,
like,
you can do that.
Months is what she said. Like, she said, like, if I don't initially declare a grade, that it could take months for that grade to be shown as a grade.
I don't think, I don't think that, well, I can't say, because I can't say what the registrar is going to do, but they have got their hands full doing this different grading system. But all I usually do is hand them a slip of paper that says change this grade to that grade, and they go in the system and they change it. Now, I don't know what kind of changes they're making to their system to make all this work, but honestly, I don't think it'll be months. And I'll tell you why I don't think it'll be months, because I think they'll be taking care of seniors that are trying to get into grad school. Yeah. Or juniors or whoever. Okay. I'm not sure that Dr. Guzman has done this process before, but that's all I do when I go in there and I say, here, this needs changing, and they go in and they change it.
Okay, awesome. I just wanted to double check on that.
Yeah. I'll talk to her about that too, but I don't think it'll take that long.
A little bit of a different stance on this grading stuff. So I just want to make sure.
Okay. Anybody else got any questions about that? Yeah, we're all working to make this be fair for everybody and come out to the best possible outcome here. So that's why I would like to talk to you about it individually, because it differs in different situations. Okay. And I think we'll take care of it. All right. Okay. Everybody okay? All right. I'll see you on Friday. Don't forget about your homework and I guess I've got all the bonus quizzes in for now. So I'll get those back. I'll try to get those back to you tonight. All right. Talk to you later. Okay. Bye.